Shout out to Cloudflare for hosting so many events of ours, 3, 4 so far, I think. So really appreciate that. This is my talk about pushing the boundary of what's possible with Code AI. And I'm just going to dive into a demo here. If someone could hold the mic, that might be helpful. Okay, I appreciate it.
Should I be on?
Yeah, like that. Perfect. Actually, I'll just copy this. This command I have here, and I'll try to keep everything on time. So basically, this is a demo I showed last time, right? It's a system that's able to pretty much answer any question you have about any code base, any open source code base. At least it can try to do that. And the way it does it is it does it by fetching the right context. It asks itself, do I have enough context? If not, then how can I fetch the right context? People call it like agentic, but the idea here is, for example, it decided to fetch a file, and it decided to actually guess a file name, file path, readme.md, and it turned out to be correct in this particular case. It's able to perform a search and so on. So that's the demo I showed last time. One thing I added since that time is I'm able to now ask a follow-up question. I'll see if this works. So I can say, and I'm asking a question about this particular separate open source repo. So I can say, what tools does it have access to specifically? Does it have the ability to perform a search, open a file, stuff like that? And it goes ahead and goes into a separate loop, gathering contexts. But it's going to take a while, so I'm just going to go back to this talk here. And by the way, this is still experimental. Thank you so much for holding the mic.
Yes, all good?
Yeah, all good. So just to set the context, as I said, I joined Sourcegraph, about 9 months ago. And when I joined, in my announcement post, I said, I'm going to be helping them push the boundary of what's possible with AI for coding and software engineering. It might sound like just a slogan, meaningless slogan. There are a lot of them, but it's not. To me, this is something I meant and something I've been focused on for the past 9 months. But you might say, okay, what does that boundary look like exactly, visually? To show that, I wanted to show it in this little chart where the y-axis represents the speed of the AI service you want to provide, and the x-axis represents the capability. And to show what it looks like and how to kind of look at it exactly, I wanted to show a different example from OpenAI. So with OpenAI, they launched GPT 3.5, which was the first ChatGPT model, which was pretty fast, but not that capable. And then they came up with GPT-4, which was slower, but a lot more capable. And they kept improving with subsequent models. And currently, this is pretty much what they have. I mean, a little bit oversimplified, but the major two things that they offer is these two models, GPT-4o and o1. And one thing you can learn from this is that you can't always optimize your AI service for every single aspect that you care about. Sometimes you need to optimize for speed. Sometimes you need to optimize for capability. And that might mean that you need to offer separate products or separate offerings in your product. And by the way, this frontier is called Pareto Frontier. There's a sort of an academic name for it. So you might say, okay, what does the Pareto Frontier look like for us, for Sourcegraph? One of the main products we have is our Code AI assistant product. It's called Cody. And the two major components of the product is autocomplete and chat. I'm just going to assume you're already familiar with these two concepts. So with autocomplete, it turned out we need a faster model that's able to deal with a lot of requests, but it doesn't have to be the most capable. But with chat, because it's more intentional, you need to intentionally ask questions. We want it to be the most capable model, like Claude 3.5 Sonnet or the latest Gemini, latest GPT models. So you can say that that's the Pareto frontier we had, let's say, 9 months ago. So I wanted to kind of walk you guys through how we've been thinking about pushing them, how we've been pushing them, and hopefully you'll be able to apply to your own founder journey, to your own AI product journey as well. So one thing we tried is we asked ourselves, can we improve the autocomplete model that we have in terms of its capability without sacrificing its speed? And one thing we tried for that is we fine-tuned our underlying open source model that we used for it just for Rust. And with it, just by focusing on Rust, we were able to do exactly that. And one more major thing that we've been working on for autocomplete is this new feature we've been calling auto edit, that is able to take in more context from your editor and give you more helpful suggestions, more different kinds of suggestions, not just additions, but also editing your code or deleting some of your code. And this is more of a trade-off, and we think this trade-off is worth it to make it more capable but a little bit slower. And similarly with chat, one thing I introduced in my previous talk is this feature that we now call agentic chat. That's a little bit similar to what I mentioned earlier, where it's able to decide what type of context it needs to answer the user's question exactly. So that's also the case of a trade-off where we make it more capable but a little bit slower. And so we've been doing a lot of different things, including single-purpose agents to push this boundary. By the way, single-purpose agents, these are agents that are able to take care of specific tasks in your software development lifecycle, whether it's generating tests or PR reviews, stuff like that. So that's how we've been pushing the Pareto frontier for us. And I've realized that running an AI company from a product and engineering perspective comes down to a few important things that you need to think about. First, you need to decide how much of the Pareto frontier you want to cover. Do you want to focus on single point? Do you want to be known as the fastest product or maybe the smartest product, but slower? Or do you want to cover multiple points like we do? It's more work, but that might be the way to offer a more comprehensive solution. And then obviously you need to keep pushing this frontier. So you want to pick a point or a couple points and then push them in terms of speed, capability, cost, or make sensible trade-offs, like I mentioned earlier. And in your organization, however big it might be, it will probably come down to the PMs to know what to push in what direction. And being able to push fast stably, the emphasis on the word stably there, will probably come down to the job of engineering managers, tech leads. If you're a founder, you might need to do all of them as well. So you might say, okay, that's kind of tough because you're always making these trade-offs. You might sacrifice speed for capability or vice versa. Is there any free lunch though? Well, there is. One is, as I mentioned earlier, if you can fine-tune your model for a specific purpose, or if you can just wait for a model provider to come up with a newer, better model, then you get benefits from that. But one underrated aspect, in my opinion, is UI, UX, and DX. Because at the end of the day, what people care about is their experience. If their experience gets better because of better models, they'll enjoy it. But also, if their experience gets better because of better UX, UI, because of better onboarding or better customer support, even, or more reliability in your system, stuff like that, then that's better experience too. And for this, one piece of advice I want to offer is measure twice and cut once. And this is kind of a silly thing because it's such a cliche. But I think in the software development world, I would say as write and read a design doc twice, develop once. And you might not agree with it, right? Like not everyone likes to write a design doc necessarily. But I think this is a good principle to have just so you don't waste time, going kind of back and forth, implementing one thing and implementing another thing and so on. Of course, you can go in the other direction. You probably don't want to write and read a design doc 100 times before writing a single line of code. But I think this is a good balance to have. And all of these, at the end of the day, comes down to these two things: completeness of vision and speed of execution. I'm not the first one to break it down this way. And this is also kind of a silly thing. It's like business basics, business 101, but it turns out even in the world of AI, business 101, business fundamentals still matter. So one more thing I wanted to add related to the demo is this chart I showed earlier. There are a couple of things that are missing. One is O3, which I skipped just for simplicity. Another one is deep research. Who here has heard about deep research? Some of you. So it's their new offering that's essentially slower than these services, but more capable and has more access to different sources of information. So I believe that in the world of code AI as well, whether it comes from us or someone else, it doesn't matter. We also need deep research for your code base. And that's what I started to develop exactly. So I'm just going to go back to the demo here. And here you can see that it decided to explore different sets of context. In my previous talk, I explored how I've done that exactly. But it explored a bunch of states and it called the LLM 14 times in this particular case. And the response says, yes, Sui agent has access to tools, including the ability to perform searches on open files, specifically Bash tool, file viewer, code editor, file map. It looks correct to me. So the reason why I said, the ability to ask a follow-up question is important is because it's natural to want this thing right here, this orange point right here, where you say to your system, I have this engineering issue that I want solved. Let's say Devin or this AI system. Can you go ahead and solve it in a couple hours? In a couple hours, come back to me with a complete solution, go. But it turns out, technically that's a really hard problem to solve, but also it's fundamentally a really hard problem to solve in the first place. If you think about a human developer, let's say an intern developer that you hire, you might tell this intern developer, hey, can you solve this bug? They might come back in a couple of days, solving it in a totally wrong way, and you need to communicate back to him again or her again. So that's the same thing with AI, but it's even more of a bigger issue. So I think being able to go back and forth, being able to communicate that way is really important for AI products in general. And that's all I wanted to cover in this talk. If you want to learn more about this kind of stuff, feel free to follow us on YouTube. Thank you so much.
So one thing that we realized from talking to our customers was, traditionally people have used business intelligence tools and these no code interfaces for defining reports, creating dashboards. And oftentimes these interfaces make a lot of simplifying assumptions about the underlying data model and what the data definitions are. So we wanted to bring this process of doing data analysis entirely into code. And with more and more people leveraging ChatGPT and other code generation tools for generating code, we were like, we should build a way to build data apps entirely with code, specifically Python. So that was the motivation behind Preswald. And also all the code from this demo, we're doing a live demo, but everything's on GitHub. So I'll just give you a second if you want to follow along. So this is a structured studio. So this is how you would create a new dashboard. So if you want to hit new project, what this does is it actually creates a new folder here with all of the scaffolding for a data app. So you can see here that we give you a sample data file, a Python script, and all of the configuration to really customize this data app for yourself. So, and then when you hit preview, what we do is spin up a service, a fast API server, and actually create a dashboard for you that you can then deploy and share and distribute, collaborate on entirely with your team. But it's what we wanted to do is make it really easy to customize this entirely. So let me show you an example that I put together before. So this data set right here. This is a very famous data set called the Iris data set. So this includes a bunch of information about the iris flower. So I'll show you like how you can actually like use our platform to like, let's say, generate more code. So here you can just hit Command M, and what it does is like it actually understands the shape of the like the initial data set, the metadata, what do all of these things mean, and it will actually generate like plots for you. And so now when we hit preview, you can actually see here, it's a second to spin up, but you can actually see that it like creates like all these really cool looking charts, and you know, you can actually go back and like have this like back and forth feedback loop. So if you want to like edit the code, you get the flexibility to do that, but you can go from like connecting a raw data source to having like a dashboard with some interesting insights, like kind of in like one like go, which is very, very powerful. Now I can show you how to like deploy this. Let me pull up a terminal. So let's go here. Let me know if the font size is too small. Awesome. So we'll go to where that is. We'll go to Iris demo. You can see all of these things are here, like all those files, and we can do Preswald deploy hello.py -- target and like structured. So what this does is it allows you to actually like deploy the app on our console. So if you go to like console here, you can actually pull like an API key from here. Let's do, I'll just copy this and save that. And here, it might take like a second to, it might take a few minutes to deploy, but the idea is like, what we do is then like create like a deployment for you. So under the hood, there's like a Docker container that gets created, but with our like CLI, you don't actually have to worry about like putting it on render or anywhere else. Like we like take care of all of that for you. And this is like right now using Google Cloud, but if you also want to like self-host it, it's really easy to do that. But I have another example that I can show you from like earlier. So here, this is like one that I'd created. So here you can actually go and like visit this. You can actually hit visit, and like this is like a live app. Like you can actually share this. Like I could probably even just airdrop this to everyone here. But you can actually see like how easy it is to like be able to share this. So you know, like basically like with like Preswald and like our studio product, like our vision was really to help you go from like raw data to like a nice dashboard artifact and make it really easy to share and collaborate on dashboards. Anything you want to add?
We really care about developers.
Developers?
We cannot stress how much we care about developers. Lucas, anything else to add? There we go. Yeah, come give us a star on GitHub. Come try us out. All open source. Yeah. Anything else?
No, that should be good.
Take any questions.
Okay, hi everybody. My name is Yi. Very simple name. My company's name is not so simple. Relari it is. And the way we got there was my co-founder is Italian, and he wanted a name that rhymed with his Ferrari. So yeah, I couldn't say no. So today I'm going to talk about agent contracts. And so Relari as a company, we've been working on LLM evaluation and simulation for a while now. And agent contracts is our latest framework for autonomous dynamic agents. So first, I want to define agents a little bit and call out how it's different from traditional AI pipelines, which was, many people still call them agents, but they're actually very intricate deterministic pipelines where LLMs is only used sporadically for very narrow tasks. And we think of agents as something where you use a powerful LLM or multiple powerful LLMs to reason and to call tools very dynamically and to reflect and handle tasks that are not very specifically written. So with these agents, where we think the market is moving towards, it comes with many new challenges with development. And here's a simple example. For those who can't see in the back, this is a meme I found on X. It says like, well, for O3, like how do I install CUDA on Ubuntu, a specific version? And it thought for 69 hours and said, you can't. So the problem with this is it's not necessarily a wrong answer. Maybe I think it's actually the right answer, but you don't really have confidence in it because you don't know what happened in 69 hours, right? And this is the problem with agents is that they go through so many different steps, and we know the planning can fail, the reasoning can fail, tool calls can fail, and these can compound. So and if you're really trying to figure out if it did the right thing or not, you can look at the traces, but they're like extremely long and difficult to eyeball compared to the single prompt LLMs before. So agent contracts, we think of it as a unified language to specify and verify agentic behavior. So specifically what it means, it's a scenario-based requirement, kind of inspired by how traditional contract-driven development in software engineering is done. So however complex your agent is, at the end of the day, it's inputs, outputs, and then something happens in the middle. So we have requirements broken down into three components: the precondition, the post-conditions, and most importantly, the path condition, which is unique to agents. And a quick example is that we built this simple customer support agent using LangGraph. And it has a supervisor, has a bunch of agents, commands, and then even a new layer of agents. So let's say there's a return scenario. So the customer wants a return, right? And a post condition will be something that must be true after the execution. So after the customer requests a return, then the database has a return transaction, right? So this defines the expected outcome. And the path condition is also important because you want to make sure that it did the right thing to get there. So it must have verified that the order is eligible for return before processing it. So this is an example of enforcing the correct intermediate steps. And lastly, precondition. This is just a way to kind of specify what the correct input space is, because you need to make sure that the customer did the right thing before saying if your agent did the right thing or not, right? The customer must have provided the right order information. So how do we use agent contract? A quick diagram, then I'll show a demo of this flow. So the first step is to define the contracts, and effectively it's just, you can think of it as a data set. And it's a collection of scenarios, and each with different tasks you care about, and also the requirements, the pre, post, and the path conditions. And the second step is to execute. So in a custom support example, we also provide simulation chatbots, which I'll show. Essentially, you can simulate the conversations as a customer with your agent. And then we log these scenarios, you open telemetry, which we also provide, and you get the traces. This is, if you use a different tracing provider, we can also use your traces. And the last step is to verify. So we verify whether your agent has executed these scenarios according to how you define in the agent. Cool. So let me show you these three steps real quick. So the first step, to show the agents, maybe let me make this a little bit bigger. So you can, obviously write these contracts very easily. You can actually write them in natural language of how you want things to happen. But here we're going to take a shortcut, which is just to directly generate them from the prompts, because the prompt already contains a lot of information of what you expect to happen. So you can put in the prompts. Here, all of the prompts I have for that line graph thing you saw. And here, the summary of the tools. You can put additional context as well. And I'm going to use this scenario template, and let's just generate 3 examples of the contracts. I think I'm using a O1 Mini or something, so it might take a little bit. So we are here generating the scenarios and the requirements in one shot. But a more realistic step is that you can first define the scenarios you care about, generate them, and then generate the requirements as well. And the synthetically generated ones are never going to be as good or as real as the things you really care about. But this is a starting point just to show you the structure. So for each scenario, we have basically some text describing. So here is customer requesting a refund. This is customer inquiring about a warranty policy. Basically different scenarios in the customer support scenarios. And in the requirements, we have precondition, post-condition, and path conditions. And as you can see, we have different tiers of requirements, like must, should not, or must not. Basically a way to help you kind of systematically think about what your agent should do instead of just winging it. And then once you have this, you can export these. This is just the JSON file. And here I'm just going to run a simulation with a previously generated contract and some human modification to make them more realistic. So here we're simulating these scenarios, and the pink bots are basically the a simulated customer, and the yellow bots are basically the customer support agent in test. So here are different scenarios, like we earlier generated, and some of them are asking for refunds, some are updating shipping, and this is going to run for a while. So this one's asking for product information, but in our backend, it already logs the traces. So to show you like a previously logged traces, essentially, well, what we do that's a little different from the traditional tracing provider is that we think of agents essentially as a state action machine. So we look at all of the agents and turn them into states, and then you can easily see what things have been happening for each state, and then after that, it's very similar to traditional observability tools. But we only do this so that the verification of the contract can be done more easily. So once you run a verification, you can get the result. Look at an example is that for each contract requirement generated, we verified if it's actually satisfied or not. Let's take a look at an example. Like for example, this one, it says, the product agent is supposed to give the details like description, sizes, and available colors. It only provided part of that when answering the customer question. So this is extremely granular, but provides a framework for you to verify that it's doing everything correctly. So that's it for my talk. And we just started a Agent Builder Discord channel to kind of help people mutually discuss about all of the different frameworks and ways to build agents. So feel free to join.
I'm the co-founder of Dagger.io. We're a programmable build engine. And like we're going to see in a minute, we can run all sorts of things other than builds. And before that, I was the co-founder of Docker. So I want to talk about containerizing your agents. I know there's a theme, and why you would do that and how. So tool calling, very cool. Fantastic innovation. Now, not only can the AI talk back at us and make things up, it can now take over our life and run things for us and replace us. Awesome. Very powerful, primitive. Everyone's building software on top of it, right? This is a very accurate diagram of how it works. You might have read it. Anthropic had this great blog post about building agents. That's the theory. This is the practice. You have a crazy person inside your code, just calling tools, messing with your environment, right? You got to manage that now. But not to worry, multi-agent will fix this, right? We're going to narrow it down. We're going to have more agents doing more specialized things. This is what's going to happen. Now you have 50 crazy people inside your code, and they're interacting with each other. They're interacting with your environment and with you in increasingly insane ways. And the complexity is just going to get worse as our agents get more complicated, more ambitious. We've seen this movie before. This is how every web application used to look like 15 years ago. And if you think it's bad now, if you think web apps are bad now, those of you who were around 15 years ago, it was really bad. These big, crazy monoliths. But then we split them up. We cleaned up the mess, kind of, right? We came up with this thing. And then a whole ecosystem around it. I know it is a theme, sorry. I'm a little obsessed with this. But this is important because what we figured out, and by we, I mean the whole dev community, is how to break down the monolith into manageable pieces, right? You take one piece of the app, and then you put it in a box, and you have some repeatability and certainty about what that box is going to do, how it's going to work. You can ship it, you can version it, you can run it several times, and you have some repeatability in what's going to happen, right? And then you can assemble that like Lego, and now you can start building more scalable, robust systems, and you get some sanity back, right? So I propose that we're going to have to do the same thing for agents, right? We're going to have to take those, insane brains and then put them in a jar and then have some control over what we connect the jar to, right? Instead of just letting them run crazy all over the place. That way we can build cool robots. So instead of this giant monolithic robot just messing around with the environment, picture these cute, adorable, look how adorable they are, these cute, adorable robots that you're building. That's your software. It's the little pieces of your software, and you're plugging brains into them. And you're making them do what you want them to do, and you control the constraints. You got these weird legs, you got the wheels, etc. You see what I'm saying? So that's what we're going to have to do. We just need to develop the tech to do it. So that's where I try to demo doing that. And this is where I need my professional mic holder. Thank you. Okay. Oops. All right, so you ready for a demo? Yes? Okay. Okay, wow, I'm doing not too bad on time. So what we're gonna try and do, we're gonna try and build Melvin. Melvin is like a toy open source version of Devin. You know Devin? Okay, we're not gonna actually build all of Devin, but we're gonna try and apply this principle of building little components that are very simple, almost comically simple, and then build up from there and see how far we can go, basically. So I'm not gonna try and blow you away with an actual replica of Devin, right? Just wanna give you an idea of what's possible with this pattern, and then encourage you to maybe come see me afterwards and talk about how we could build it together. That's the idea. Oh, yeah. Is it better? Bigger? Oh, good, okay. Oh, you got a pretty young audience then. I can't read this. Okay. Right, so this is a Dagger module. But first I gotta explain what Dagger is, okay? So Dagger is an open source engine. It's a tool. You install it on your computer. I have it installed here. You install it on your server, and then it acts as a runtime. A runtime for what? For your builds. So you hit its API. You got SDKs in Go, TypeScript, Python, a bunch of languages. Or you can call it from the command line. We have a little interpreter. And then through that API, you dynamically construct a DAG. A DAG of what? A DAG of immutable artifacts and the functions transforming them. What's an artifact? Container state. So a container snapshot, directory snapshot, file, secret, reference to a network endpoint, things like that. And then you just transform and transform and transform. And you're building this DAG, and that has great properties, like it's very cacheable, it's very repeatable. And we use that with our open source community. DevOps engineers use it to make their builds very repeatable, very scalable. And then, actually, before I go to the end then, let me show you what it looks like. So this is the little interpreter I was talking about. Dagger shell, it's a little interpreter. But under the hood, it's calling the Dagger API. So what I'm gonna do is call functions like container. Is this big enough? Okay, bigger. Okay, like this? Okay. So I'm typing a command that looks kind of like a shell pipeline. Container, pipe this, pipe that, right? But it's actually hitting a completely typed, discoverable API, right? So I'm calling a function, I get a container. Now I'm calling another function, downloads an image. I'm gonna call another function, add a file with new file. Hi. Oh no, wait, actually. Yay. Someone dared me earlier to say that my favorite language is PHP, so there you go. Are you happy? You said it. So I'm building a container with a container or a directory or whatever, and I can just build up and build up and build up, right? And so here I'll just say, give me a terminal. So I'll just run that. It's gonna run it, got some caching, boom, I got my container. I'm in a container with that little yay.txt file that I built, right? I exit it, it's gone, it's in the cache, and I can iterate again. Okay, let me add this, let me add that, right? That's how people use Dagger. Think a picture like a Docker build, but with an API, some SDKs on top. And then you could keep building from there. So we got some very large teams automating their builds with this. But then what happens when you start automating your builds with this? And they're containerized, right? It's all running in containers. So it runs the same in CI, local machine. That's kind of the benefit. Then you realize, hey, wait a minute. I can run anything with this because it's programmable as long as it's shaped like a build, like it's a DAG of immutable states with functions transforming them. And then we have an open source community going out there and looking for things that look like that. Oh, I can Daggerize my tests. I can Daggerize my deployments. I can Daggerize my data pipelines. And then one day, someone said, hey, I can Daggerize an agent. Because guess what? LLMs work like builds. LLMs work in the pure world of math, right? They have an immutable state. It's their context. Then you call a function. You add data to the context, a prompt, a reply, tool call. That's all immutable state transformed by functions. So it turns out it works great with the Dagger API. So what we did, this is a dev version of Dagger. This is the part where it might blow up, is we added a primitive called LLM. So now I can just call LLM. This gives me an immutable empty LLM state. Here it's a GPT-4o. We just plug it on, any model basically. And then I'm going to chain operations. So obviously I can add a prompt, like that's easy, you know, but I'll show that after. I guess, should I show it? I'll show it. With prompt, you know, name is Bob. And then I can get the history so far, right? You know, by the way, this is all traced with OpenTelemetry. And we have a cloud service that shows you the traces. It's great. You know, it's talking back, whatever. Okay. So far, so good? Okay. So the cool part, obviously, you don't need like this whole thing to prompt. Like that's easy. The cool thing is the tool calling, right? So to call tools, what do you need? You need functions with typed arguments. You need a schema, right? Well, we have that. The whole Dagger API is made of objects with functions and typed API for these functions. And then also we have the state, right? We know the state every step of the way because we have the whole DAG. So what if you could take any object, say, for example, this container that I built before, and then I call LLM and I say with, you can say it's auto-completing here, not a cache volume. Nope. Container, yes. What Dagger did is it detected all the types available in the API. And then I can give it as an argument any object of that type. For example, this. Can you see it? Oh yeah, remote terminal, better? Okay, so I gave it the container. Now what's gonna do is Dagger automatically is gonna detect all the functions available in that container object, and then it's gonna plug them into the model and say, this is your environment now, right? It's connecting the robot body to the brain. Call it the BBI, the body-brain interface, because it sounds cool. And then I can keep chaining. So now I can prompt it. I can say, I'm gonna try and prove here what's going on. You have access to a container. By the way, just keep in mind, everything I'm doing in the terminal here, you can do in code, right? So picture yourself writing something that looks exactly like that, but you're chaining function calls in Python or in Go or in TypeScript. We're gonna get to that in a second. You have access to a container. Read the file, yay.txt at path. Okay. We haven't solved prompt engineering. At exclamation point. It mentions the programming language. Install on the container what is needed to develop in that language. See what I'm saying? Like, okay, we're trying to have create some sort of a toy agentic loop here. I'm not saying the language that I only promised I would name it once, so I'm not going to say it again. Okay, and then I'm going to look at the history after it does that. Go. Okay, so it's calling. Okay, wait, it's going too fast. Wait, okay, I'm going to go to the browser. I'm going to look at this trace in the browser. Okay, so this is my trace, you know, all OpenTelemetry. You can go back and say, what did it do? Okay. I prompted it here. Oh yeah, thank you. Please get the reminders, thank you. Okay, that's my prompt, right? Where is it? You know what? Actually, I got the history back. It's done. Let me just do it here. Sorry. Okay. Go back up. Again, I have to make it smaller now. Sorry. Okay, wait. Is this still readable? No. I'm trying to see the whole thing in one shot. Is this readable? Okay, so at the top you see my prompt. You have access to a container. This is just rendered on the terminal from the trace. So the trace you can look at in the terminal, save it for later, whatever. So you got the prompt. Then here's the magic. We plugged that container object. It has a function called file. It's in the Dagger API. And it's all, you know, documented. So the model said, okay, I got to read a file. Okay, file, cool. It returned an ID. Okay, let me look up the contents of that. You can see here the API returns. My favorite language is beep. And then it said, okay, I'm going to do what was asked and tried to execute. That's also Dagger API. Let's apt-get update. Error, because it's an Alpine container. I think it's the, what did I give it? I forget. Yeah, Alpine. So error, it gets the error. Second shot. Okay, let's try APK. It tried to, okay, made another distro. It worked. So now it's going, okay, I'm going to install PHP, blah, blah. It got an error. It's like, am I doing this right? What is distro is this? You know, so this is the agent figuring things out and looks at the results. yeah, okay, it's Alpine, so what's wrong? Blah, blah, blah. I don't know what was wrong. Oh, it figured out, okay, just one of these doesn't exist. I'll just install PHP. Good enough. Okay, I'm done. Okay, I did it. Basically, it's saying, I did it. Okay, did you do it? How do I know? Well, I can get the object back, right? So I'm gonna query back from the state of the LLM, give me the container back that you modified. And now I'm back in what I was showing in the beginning, right? It's just it's a function that returns a container. And then I can say, all right, let's get a terminal in there. So, oh yeah, and let's bump it up. Wow, so good. And then we're back in the container. We got yay.txt, but normally PHP is installed. There you go, the agent installed PHP on its own, okay? So that's the primitive. Oh, I'm over time. I'm gonna try and finish real quick. Sorry. Okay, so how do we use this here? So here I'm writing a module, and a module is just a little bit of code. This is, that extends the Dagger API with my types and my functions. And then any other client, like someone else using the shell, can call that, right? And so this is my Melvin module. It's got a new type, Melvin. And I filled in the magic, right? This magic goes here. It's going to be a function. We're going to write a function that takes an assignment, like this is the program I want. And it's going to return a container with a Go program ready to be built,
Wait, why is it called Melvin?
Oh, it's called Melvin because it's a joke on Devin. Devin, Melvin, yeah. Open source clone of Devin, yeah. Had to name it something. Okay, so what we're gonna do is we're gonna take this little modular approach. We're gonna write the smallest possible object that Melvin would need to get work done, right? I'm not gonna give it a full container object. I could, but it's gonna get lost because there's just so much to do. I'm gonna just constrain it. This is the magic of agent development, right? You wanna be in control of the constraints. Sometimes you wanna give it a lot of tools, sometimes very little tools. It should be very easy to kind of decide and change and split, right? That's what we're looking for, like a rapid iteration loop. So here, I'm gonna look for a module that someone else wrote, because there's a whole community out there making these Dagger modules already. I'm gonna look for one that I actually wrote it, spoiler, but the demo. 3 functions. What do you need? What's the bare minimum for a workspace? You need a container, in the state. Then you need a read file function, a write file function, and then you need a build function. And I'm going to really make it simple. The build function doesn't even take arguments. You just build. So I'm going to hard code this to be a Go environment, right, to make it simple. So I'm going to give the model an object with 3 buttons, basically, like read file, write file, and then does it build, and that's it, and constrain it to the max. So I'm just going to show you the code for that. I wrote it. It's called Toy Workspace, and I called it Toy Workspace to emphasize that I wrote this. It's 49 lines of code. You can write this. This is Go. It could be Python. It could be TypeScript. And if you see here, you recognize container dot from dot. Okay, mount a cache volume. Change the work tier. It's basically Docker file, but in code, right? This is my type, my toy workspace. It's a type with just a container in the state. And then read is 2 lines. Oh no, it's 1 line. Take the path, and I get that container in my state. I get the file. I return the contents. Write, the opposite. I take the container, I add a file, and notice you can see the immutable nature of it. It's getting me a new immutable container, and then I'm setting it in my state, and then I'm returning a new state. So you can see the chaining. And then build is like, I'm going to execute go build in this container. That's it. That's it. Okay, so I'm going to use it. We're going to use that now. Let's go back to my little magic goes here. I can't read it. The hell, where is it? Main.go. Oh, there. Thank you. Okay, so I pre-wrote the version that actually works. It's down here. Ta-da! Okay, I'm just gonna boop.
Cooking show.
Go program that actually works. Yeah, I pre-cooked this. Go program. Okay, here's the magic. You ready? Ta-da! It's 8 lines. Wait, 7 lines. Okay, so here's what we're doing. I installed that other toy workspace module. Right? You do something like this. Dagger install toy workspace. You can do this over GitHub also. Like you can install some random person's module. And then magically, you have bindings. So now I can instantiate a toy workspace. So this is my workspace before the agent, right? Just give me a workspace. Then I instantiate an LLM. I give it my toy workspace, right? Notice that it can magically recognize that type. A little bit of prompting here, nothing fancy. Show you the prompt, really basic. I'm not a pro AI engineer at all. This is my prompt. You know, you're a programmer, you have a workspace, please use it. Please don't use this thing, you know, can't handle it. Here's the assignment. And I just have a tiny little variable system. I just take my string here, I put it here, prompt var, and then boom, I can put it here. This is the basic prompting. Okay, that's the loop. It happens here. I just give it the file, right? And then I get the workspace back. Same thing I did with the container. Give it the object, give it the prompt, loop, get the object back. And then that's after, right? If my IDE, by the way, autocompletes all of that, right? I can say, okay, that's of type toy workspace. And here, if I wanted, I could say container with, oh, it's not working. Oh, with new file. See what I'm saying? It's the same type system. I can just keep chaining stuff, but I won't. I'm gonna keep it simple. Get the container out of the workspace, return it, boom. Okay, so does it run? Let's see, let's find out. I gotta reload this. So I'm gonna relearn the shell, it's gonna load the current module. So now, we have this 8-line function calling this 49-line object as an environment and plugging it into LLM.
Can you make it slightly bigger one more time?
Yes. Yes, sir. And now, in addition to all the other stuff I called before, I can just call Go program. Then I can say, write me Perl clone. We're going to keep it simple here, okay? Yeah. Go. Okay. So now it has only these 3 functions. It tries to read main.go. See that read? That's my function that I wrote. And it fails because there's nothing there. Then it writes a file. Oh, it's writing a file. Then it's calling build. And build worked? No, I don't believe that. Oh, no, wait. I'm going to go see that in the browser. Let's go find out what happened here. With some cool emojis, maybe. Oh, yeah, that one's going to be cool. Okay, wait. This is our tracing central. This is our team. You can see everyone's traces from the Dagger team, just like running stuff. Pretty cool. This is our CI on the left. I can give you a tour later if you want. Okay, so this is what happened. Prompt tried to read. See that? Am I bigger? Making it bigger. Tried to read main.go. Okay, no main.go. I'm going to write main.go. This is what it wrote. You know, code that we know it knows how to do that. And then it called build. My build function that I wrote that I showed you, right? And what did it say? Did it work? No, see? It said, you forgot the config file. You forgot something. And then it said, okay, oh, right, I forgot the go.mod. And so it added a go.mod. And then it called build again. And then build said, by the way, I can keep inspecting, like, what did build actually do? And you can see, yeah, it did the with exec of go build, the thing that I coded before. So you're not just seeing traces for the LLM part. You're getting the deep traces of what actually is happening all the way down, right? All the way to the source of truth. Okay, and I guess it succeeded. It's trying to write. All right, okay, it's trying to fumble its way through. I don't know if this is gonna work. Okay, well, I did not give it access to a shell, so it has to kind of, it doesn't have the tool. If I had like 10 more minutes, I would give it a shell. Okay, and it said I succeeded, so let's see. Let's get it from the cache, and now let's just get a terminal. Okay, did you succeed? This is the thing. These are the files. Okay, looks okay. Should I build it? Should I build it? Okay. Who thinks it's gonna work? Okay. Oh wow. That's like an even 50-50. Okay. I choose to see 50%. Choose to see hope. Okay. It build. Okay. Oh yeah. Right. Okay. It works. All right. So yeah, that's it. Sorry I went a little over time. And you get the idea. I mean, we didn't replace Devin actually, like, because building a real agentic product is a lot of work, but you should be able to build it from these small protos, and also there should really be an actual software ecosystem, an actual open source ecosystem where we can reuse each other's stuff, right? And there isn't. There isn't really. And so like we propose Dagger as that ecosystem. But also, if you want to copy what we're doing and try doing better, then we'll copy the ideas back, and then everyone will be even happier. This is Daggerverse. This is where all the modules are. So you can see we've got a big ecosystem of all DevOps engineers, actually. And they're open sourcing everything that you could possibly hope to do as part of your agent. It's in there. You can just, all of that can be plugged into an LLM now, and you can build agents on top of it. So think of it, all these startups that are kind of selling you this really fancy infrastructure to solve these problems. Well, basically, that's open source now, and you still got to buy hosting for it, but it should be commodity hosting. It shouldn't be expensive, specialized hosting. It's just VMs and storage, people. Okay, so yeah, that's it. Thank you. Oh, wait.